recognized that certain ones were really hazardous. A lot throughout on this slide and on other slides moving forward today, I'm mostly going to be highlighting these two PFAS chemicals. So it's PFOS and PFOA. They're both a long chain. They're very, very sticky. They like to stick to sediments and soils. And so they accumulate the most in the environment. They're also problematic because they can cause health problems at a very, very low concentration. So that's why those are the ones I'm focused on here. And so those were phased out of production around this time. In terms of actual advice given on what limits should be in drinking water, started to be introduced in 2016 by the EPA as a health advisory, meaning, hey, if you're at 70 parts per trillion or more, that's going to cause health problems potentially. But a health advisory is just guidance. It's just information that you can respond to if you want. It's not an enforceable standard. Then in 2022, the EPA proposed actual limits that were enforceable at 4 parts per trillion. There's been some adjustments in how PFAS are being regulated at the moment with changes in federal administration, but that's the most recent number put forward by the EPA. Now, one thing to note is that when the EPA comes up with an enforceable standard, states are required to adopt that standard, but there's buffer room. And so it takes time for the regulations to work their way into state regulatory systems. And then in addition to that, it takes time for people to respond to those regulation changes. And so even though this was proposed in 2022 at 4 parts per trillion, the state still hasn't actually set a limit to that. In 2022, they finally caught up to the 70 PPT based on the health advisory. It's the legislature who dictates these things, and so it's a very slow process. Okay, in Eau Claire, well, around the state, since before 2019, PFAS have been popping up in water supplies, like municipal water supplies, and then in 2020, the city of Eau Claire found PFAS in our drinking water from the well field, and in 2021, they took about half of the wells offline, meaning half of the wells that are pumping are not supplying water to the city. Only about the other half that are not as dirty are. And so, they could come up with a long-term solution. And so this is sort of where we're at. Now, to give you a sense, so I keep using this 4 parts per trillion, that's a very tiny number. That's very hard to wrap our head around. So, at least for me. So here's my comparison. If you take the entire state of Wisconsin and you put these 4 computer bags around the state, that is 4 parts per trillion. The area of the surface of one bag is 1/1,000,000,000th of the area of the state of Wisconsin. So that's the levels we're talking about, very low. But I also think it's really impressive because we have analytical equipment that can detect that low. Could you imagine being find those 4 backpacks in the entire state, right? But it can do it. And so it's a very tiny number. And also we have very impressive equipment that can do that. Okay, so in the state of Wisconsin, about 4.1 million people rely on municipal water supplies for their drinking water and other water uses in their household. About 1.7 million people rely on private wells. Municipal water supplies are regulated. And so if there's a federal enforcement for some water quality standard in place, municipal water supplies are required to test and treat. That it's required. Private wells are not enforced or regulated in that way. There's only a couple circumstances where a little bit of testing might be done. Does not have to be done routinely. If there's an issue, it's up to the owner whether or not they fix it. And so up until somewhat recently, municipal wells have been the primary source of data for PFAS because there's no enforcement for private wells. There was some things where we're like, well, it's probably more of a city problem for the sources and stuff, but that's not actually true. So in 2022, my research group was awarded a grant through the county to expand water quality testing in private wells within the county. our main focus originally was your like regular water quality issues like nitrate, bacteria, metals, and then a little bit of PFAS. But then in 2024, during a little bit of routine sampling, the health department found exceedances of PFAS a lot, a very high amount of PFAS in rural areas in Southwest Eau Claire County. And so since we're working together on this project, we collaborated to increase the amount of PFAS we were sampling. They provided us with additional financial support to do that. And some of the work that's been done around the country has suggested that PFAS could be sourced from land spreading applications, like, wastewater treatment, sludge, and paper mill sludge, and those kinds of things. And so it's a reasonable place to start. And so we started by targeting private wells that are located near land spreading sites, or approved land spreading sites rather. And then the health department also put out a public service announcement so that we could catch a little bit of a broader net. So we weren't only restricted to only land spreading sites. And then we collected samples, we sent them to the Wisconsin State Laboratory of Hygiene, and they were tested for anywhere from 33 to 40 PFAS, including the 18 that the EPA suggests. All right. This is a map of Eau Claire County. And so the boundaries are here, a nice rectangle. Okay. Got our surrounding counties. This area here in like Drammen, so these are all the townships plus cities in the county. This area in Drammen is where the health department first found a number of exceedances. And the way the health department operates is when they have, at least with the PFAS, but for some other things too, when there's an exceedance, they send letters to the people who live in like a half-mile radius of that house to say, hey, nearby you, there's been a detection. You should probably get your water tested, like as a recommendation. And so as a result of that, some people would, and they kept finding more and more and more and more until they ended up with this. It's like these huge exceedances all around Drammen and up into Brunswick. So we expanded on this study in partnership with them. And I'm going to orient you to this map for a moment. The data that are on here show both our research groups, data collection, plus all of the stuff that the health department has collected separately. All right. All of the little squares that are kind of in the background, the colorful squares, those are sites that have been approved for land spreading. There's 4 different kinds. The pink colors, that's a paper mill, all right? And those are all over the county. The orange is industrial spreading. There's just a little bit of that. The green is sewage, like municipal waste spreading, okay? And that's the green. So we've got a bunch of that all over. And then the blue is septage. Like you have your private like septic system, and the people who come and clean it out, they have to do something with those byproducts. And so after it's all in good shape, they sell it. Well, they don't sell it. They partner with properties to spread it on their property. So it's free, but it gives them a place to put it. And then the property owner also doesn't have to pay to fertilize their crops. Okay. So that's a very common practice that happens all over the place. It's been going on for decades and decades. And it theoretically, it's a safe practice. It's supposed to be good. It's a way of reintroducing nutrients to the environment. But then, of course, you end up with something that you didn't know was there that ends up in the byproducts. And so here, so all the squares are the land spreading sites that have been approved by the DNR. So it doesn't guarantee that there was spreading there, but probably. And then the circles are places that were tested. So if they're a gray circle, it means we tested it and there was no detection of PFAS at all, and specifically PFOA, which is a good representation of like collective PFAS for this study. Okay. If it's orange or yellow, I guess it shows more on the screen, yellow, that means that we detected them, but they were below the 4 parts per trillion. And if it's red, it means it's above 4 parts per trillion. Now, some of them were like 4.1 parts per trillion. And then there were some that were like 300 parts per trillion. So this map does not discern the severity of contamination in a single sample, but from a health perspective, it's like, well, it's an exceedance, right? And so you can see the number of samples over here. This is health department. These were our samples. We had a couple in here, and the health department started spreading out over here and getting some more once we started getting a bunch. This is Fall Creek. And then we had a couple that seemed kind of random, like north of Altoona. I have no idea what's happening up here. And interestingly, these were all sampled as part of from the press release. People were just like, I want my water tested, and we're like, okay, you know, and we did it. And it's like all of these detects and exceedances, but there's not really, you know, evidence that there's land spreading up there. So just from, you know, a quick look at the map and trying to like make sense of the patterns that we're seeing, like preliminarily, we mostly see exceedances overlapping with paper mill spreading in here. There are, you know, in here you also get sewage and industrial spreading, but you don't necessarily see those types of spreading represented where you have other groups of exceedances. So that's sort of our hypothesis, is that it's related to paper mill spreading. Now, you'll notice that there are places that have paper mill spreading where we've sampled and nothing pops up. Two things. One, groundwater contaminant concentrations are not straightforward. You could have like a screaming high number and your neighbor might have a non-detect. It's very, even with like simple contaminants, is very complicated in terms of identifying source and how it's being distributed through the system. The other thing is that PFAS were phased out somewhere in this, you know, 2011 and 2016, specifically the PFOA and PFOS, and land spreading existed before and after that. And so some of the data that we have is more modern land spreading sites, and some is more old. And so this kind of crude map of paper mill spreading sites, you can like, it's the same thing, just on Excel, okay? All of the ones that are in orange are pre-2014. All the ones that are in green are post-2014. It's not like the most like perfect way to do it, because just because something stops being produced doesn't mean it stops existing, but it's just what we did for this initial look. And so we can see at least that the places where we're seeing the exceedances do align with places where there was some old spreading, but then some places you don't, right? This is all old spreading, but we did a ton of testing in here and there was nothing. And so there's still a lot to do in terms of like really like picking apart and weeding through like what all factors might be that influence this, but kind of an interesting thing. The other thing we need to consider is how deep the well is. Groundwater is a three-dimensional problem. And so, you know, you have your well positioned near your house. So that's like geographic location, but then there's also depth to your well. And not all wells are the same depth. You drill until you get enough water, or until you are, if there's a contamination issue, you drill until you think you're probably beyond the contamination. It's just how it is. And so here is a diagram that shows a well construction nearby this house with the opening to the well, the place where the water actually gets in at the bottom, right? And so how deep this is will dictate where exactly depth-wise your water is coming from into your house. Now, if we're talking about land spreading as a source of PFAS, that's happening up here, right? And so it has to kind of work its way down through here, and then it hits water, and then it's flowing with the water. But in theory, in the most basic conditions, the shallower your well, the closer you are to the source and the higher your contamination should be. And so we wanted to weed apart some of that. And so we pulled well construction logs for as many of the wells as we could get. This is a form that is completed for most well constructions that has a ton of different information on it. But what we're most interested in is one, how deep the well is, but also what is the geology that they're drilling into. And so you can see here for the first 30 feet, it's in this particular well, it's sand. And then there's 5 feet of clay and gravel. And then the last 25 feet are also sand. So from that, I can say, okay, and I know there's more down here beyond the screen, but I was like, I know that this well is 60 feet deep. I know how big the inlet is. So I know that it's in a sandy, like the water is flowing into it from sand. All right. And that can be really potentially useful in certain types of contaminant issues. So when we plotted a subset of the PFOA data against well depth, we found that the wells that had exceedances were all up here. And so that at least is like consistent with what we kind of expect. This plot does not discern how geographically close or far they are from a PFAS source. So it's just, we just dumped it all into this graph for now. But it at least shows that the highest concentrations are pretty shallow. You can see they get pretty high. The health department got much higher ones than this. This red line indicates that 4 PPT health advisory standard. We don't see an obvious relationship yet between different types of geologic units, if it's like sand or sand and gravel or sandstone or that kind of thing. But we also don't have like a ton of data that have well logs. And so we'll do the best we can on that, but it needs a little bit more analysis. The other thing that we looked at was the correlation between nitrate and PFAS, because nitrate is commonly sourced from crop fields and things because of like fertilizer application. And we assume that PFOA is probably coming from crop fields with like land spreading application. This is a map that shows nitrate. I know I don't have the PFAS map up here, but I do have this showing that any place we saw really high PFOA did not have high nitrate. And the places that had high nitrate did not have high PFOA. Now that might not be true everywhere, but it was what we saw here. And this is incredibly important because there's not a whole lot of PFAS data. It's very expensive to test for PFAS, like $400 a sample to get your water tested. And so, then you have like this state agency, like the DNR, who's trying to like scramble and figure out like, how do we get people clean drinking water? And so they were using nitrate to guide their decision-making about what places were maybe going to have high PFAS or not. Do you qualify for a new well based on your nitrate? Where should we look based on the nitrate? But this indicates that you cannot use that reliably as a proxy. You really just need to test for the PFAS. I want to quick shift gears just to highlight a couple things related to the city PFAS, which are sourced probably from a different thing than the PFAS that we're finding in our study. They were detected in 2020, and in 2021, the city sent out this letter. We're going to do all of this stuff to help manage it. We're going to take the contaminated water, we're going to put it in a pond, and then we'll only send the clean water out to the city. We're working on a long-term solution. To give you a sense of what the heck they're talking about, here is an aerial map view that shows here's the water treatment plant, and the well field extends up through here, okay? Here's the airport. We suspect that the source for PFAS in this area is probably related to firefighting foam that was used at the airport. Here's the discharge pond, okay? And then these are the wells that were primarily contaminated. There's wells down in here that were not problematic in the way that these were. So I want to look at a side view diagram so you can see like the A and the B here. So here's B, here's A. So we're looking at it from the side. This is the general landscape. You've got the Chippewa River, the airport's up there. It's up on a hill, and then it kind of drops down into the floodplain, and the Chippewa River is down in here. If we were not doing any kind of pumping in this area, this is what the flow conditions would look like. This blue dashed line is our water table, and water would flow from the hill over to the river. That's how it flows in this entire area, from high to low towards the river. Once you add wells into the system, not talking about contamination or anything, you start removing water locally from these little spaces. And so you're gonna drop the water level slightly in those places and you'll get localized flow into those wells. The water then gets removed and sent to the water treatment plant for processing. Some water is still gonna flow, like the big scale flow is still towards the river, but it gets sucked up locally. Now there's contamination in this. So what they did was they expanded the size of this pond to collect the contaminated water. And so for the wells that are contaminated over in that area, instead of sending it to the water treatment facility, they pump it out, they dump it in the pond, and then that just flows, becomes part of the water and flows into the Chippewa River where it will get diluted over time. So that's the system. And it actually works very well. It's a good solution short term. Okay. We sampled one property up in Chippewa County that was on the other side of the airport. And we think probably they had high PFAS. We think probably that is related to the same stuff as our well field between the airport and the river. So probably. We also saw, interestingly, that the distribution of certain PFAS substances were very different relative to what we think is paper mill sludge. Because you're going to use different types of PFAS in different amounts and different things. It depends why you're using them. Like, what is the outcome you're trying to get for the thing that you're making? And so it's interesting. They all had, you know, all of these 4 particular ones in common. But for example, you know, this one was much higher in the firefighting foam than in the paper mill, but PFOA was much higher in the paper mill sludge than the firefighting foam, which I think is useful because you can't always, you can't tell just by collecting a sample where it's from. Like it depends, but usually you can't. And so if you have a sense of what you expect the relative distribution to be, that can guide you and help you understand like what might be the source. So after the city put into place their pumping into the pond, which they've been doing for the last 5 years now, they went through a series of tests right in the water treatment plant, testing out different kinds of filtering materials so that they could build big filter at the water treatment facility. The general idea here is that you put water in the top, it flows through this granulated material, this media, okay, carbon, for instance. And when it comes out the other side, it will be clean because there's a reaction between the contaminant and the media it's flowing through. Sometimes it just kind of sticks to the surface. Sometimes it's a more of like an actual exchange of ions, but it basically gets stuck in the media and the water flows through and should be clean on the other side. What that means, though, is that your media is contaminated and needs to be changed out every so often. And so the city is contracted with a company to do that. This is what it actually looks like. Here's a picture of the media. It kind of looks like sand, but it's not exactly sand. They've got these huge, like 16 of these giant tanks that water will flow through. They're in this building. The rest of the water treatment center is over here relative to the building. And that's what they're going to do. Now, a question I get very often, and this is, I'm just about done, is why we can't just like pump them out or get rid of them. But it's related to what I'm talking about here. Like it's sticky. It's sticky. And so it likes to stick to sediment surfaces. Not all PFAS are the same amount of sticky, but they're all sticky. And so in practice, if we actually wanted to remove them from the ground, we would have to dig up every piece of ground that the water that was contaminated flowed through. It's not practical or really possible. These just can't be done. And so the best solution is to treat it once you remove it from the water. There's other contaminants like that too. This is an example of one. And then, so our PFOA, PFOS, the ones we've been talking about, those are long chain. Those are the most sticky. So they accumulate a lot in sediment. Gen X is another group of PFAS that are talked about fairly often. I didn't specify them here, but they're a little less sticky. The ones that are the least sticky means it's just moving the most in your water. These become more like an issue with long-term secondary sourcing. But the reality is that every single one of these is very persistent in nature. So I will leave you. I'll come back to this, so if you want to scan this, you can. These are Wisconsin Department of Health Service recommendations if you do test your PFAS, your water, and there's PFAS in it. But in terms of treatment, cost depends on what you do. If you do whole house versus under your sink, reverse osmosis is going to get rid of the most contamination. A granular activated carbon filter, which you might use for other things, can work for the really sticky PFAS, those long chains, but not necessarily all of them. These will not remove PFAS from your water. So if you're on a private well and you have this stuff, you cannot rely on that to remove PFAS. Okay. Otherwise, I'm going to swing back here in case you want that QR code. But otherwise, our plan is to continue a lot with like statistical analysis of trying to discern like where the risk really is, you know, how risky it is to live near or within some proximity of these potential sources, and distribute that to the community in a way that is informative but not alarming. So anyway, thank you. Are there any questions? Yeah.
There's that sand but not sand material that's cleaning and, you know, holding PFAS. What happens to that sand once it's spent? Where does that go? Is it floated?
Yeah, it's considered like hazardous waste. And so it gets disposed of and isolated in another area. I'm not actually sure where they're taking that particular media. Do you know? I don't know. It's not just dumped in like a land or like our landfill or something though. It's like there's proper procedure and like agreements for where certain types of waste are allowed to be stored. A lot of waste is disposed in that kind of way. Yeah. Yeah.
So thanks for this talk, Sarah. I mean, this is such important work that you're doing, and I think impacts all of us, certainly in this room and across the country, which then raises my question of knowing that the current administration is rolling back some of the climate regulations. Is this a potential target for?
Yeah. So the current administration, as housed within the EPA, currently has already rolled back a lot of PFAS regulations. But to my knowledge, the PFOA and PFOS and Gen X are still, they've left those be. But here's what I'll say about that is that even if you have a big overturn in the administrators who are making those decisions every few years, you're not going to see giant swings like that happen on a local level because there's such a lag in how people respond. And so, you know, so our municipal treatment system, for instance, saw the problem, they saw the health advisory limit, and they were like, we need a solution that is going to meet that, whether it becomes enforced at whatever level or not.
Kind of bouncing off that, I know that at the state level of Wisconsin, they have approved $150 million of funding for PFAS related items, but it just hasn't been released yet. It's been 2 years since that has been approved. So
yes, and there are literally like last week ongoing conversations between the legislature and the DNR. So you're right, funding has been approved, but not released for it. And that funding is meant to support municipalities to build the infrastructure they need to clean up their water. Also, a lot of, so like our municipality as well as others are relying on lawsuits to help clean up. So we've gotten, I don't know, like $10 million or something in lawsuits, like 3M and DuPont and like places that they got sued like crazy in response to the PFAS stuff. And that money is also helping to support building of this infrastructure. That PFAS treatment plant's $20 million in the city of Eau Claire. And we're like we're not a huge city, right? And so it's going to be incredibly expensive for everybody. But that's what the legislature is looking at. They're being like, this is crazy expensive. Why would we want to make the regulatory standard tighter? Because they're thinking about it from the financial perspective, despite the fact that like that doesn't change what the health advisory is. You know, you can say the limit is 70, But if it's unhealthy to have 4, you can't change that with legislation. So it's very complicated. Yeah. Yeah, Mike.
Thank you for doing this. I think one of those little dots was actually my well, my property, but how far back do the records go for the well construction information? From the
So they go back pretty far, but they get sloppier as you go farther back. Like there's less consistency in if they all have one or whether they're digitized. And so we do have some digital well records going back to like the 70s and the 80s. But more likely than not, we find them more consistently for wells that are less than 15 years old. But it also depends because if you have like a housing development and the construction crew will drill all the wells for the development and it's not associated with a person or a specific address, it's just this development. And so it's hard to sometimes discern which wells belong with which properties. Yeah. They go back okay, but I mean, it just gets messy the farther back you go. Scott.
So your Seymour Altoona mystery well,
I know.
when these wells are cased, is there casing? Are they open bore or?
It depends.
So my question, is there a chance that there could be anything in the casing that could have led to that high number? Or when people have their own wells, they will sometimes pour bleach down? Is there anything else that might be poured down? Could they have caused the contamination themselves instead of, because you don't have any other source for it that you're aware of?
If it was like one well, maybe, but there's a whole cluster. And
North of Altoona.
so, yeah, so the question is, could they have caused it themselves? So the other thing that I didn't specify is that the land spreading records that we have only go back to the 90s. It is possible that the records prior to that are all in like a cupboard somewhere. And I haven't looked through those. It was one of those things where like, well, if we feel like we need to do that later, we will, So it is possible that there was biosolids spreading up here more than what we see with these couple little dots, squares, and we just don't have the records for that at the moment. But could they be causing it themselves? Let's see. I mean, it's possible that the community had like a dumping site nearby that was being used at some time, and I mean, they are pretty clustered, but you also have all of these detects that aren't exceedances, but I think are meaningful, and they're pretty spread out, I think, to like originate from a single household. So unless everybody is collectively dumping stuff down their well, I wouldn't think so. The other thing is that thinking about it, I didn't see a super big difference in the PFAS substance fingerprint. We were looking at like firefighting foam versus the paper mill. I didn't see a huge difference. So I think what I'm more inclined to believe for here, like the signature here didn't look that different from other places. So I'm more inclined to believe that maybe there was some land spreading that either wasn't documented or that predates the documentation we have rather than somebody dumping stuff. But I also don't have a good indication for what like septic PFAS fingerprint would look like. Like, I don't know, because I don't have an obvious, like I don't have a known source to equate that to. And so it's possible, but I'm unsure. And the landscape up there, like so the airport is over here or up, wait, where is it? Over here. Right, but
Yeah.
this is not, like water is not gonna flow. Actually, it's up here. It's not gonna flow like that. So that's definitely not. So we're like, oh, I'm kind of near the airport. And I'm like, no, no, you're not, no. So, yeah.